Have you ever wondered how your email service filters spam messages so accurately, or how movie recommendation systems seem to know your taste so well? In this video, we'll explore the world of machine learning algorithms, specifically the Naïve Bayes classifier and the Case Nearest Neighbors, or KNN classifier. These algorithms are the unseen heroes behind many everyday technologies, making our lives easier and more efficient. From spam filters to recommendation systems, they work tirelessly in the background, analyzing data and making predictions. But what exactly are these algorithms? How do they function? And why are they so crucial in the field of machine learning? To answer these questions, we're going to delve deep into the realm of machine learning, starting with the Naïve Bayes classifier. As we navigate through this fascinating journey, we'll unravel the logic and mathematics behind these algorithms and understand their impact on our daily lives. So, are you ready to embark on this adventure? Stay tuned. So, what is the Naïve Bayes classifier and how does it work? Well, let's dive into it. The Naïve Bayes classifier is a simple yet powerful algorithm that operates on the concept of probability. It's called naive because it makes a rather naive assumption that all features are independent of each other, hence its name. The backbone of this algorithm is the Bayes theorem, a fundamental concept in analytics that plays a crucial role in decision-making processes. It deals with conditional probabilities, which is simply the probability of an event given that another event has already occurred. In the context of the Bayes theorem, we have some key terms to understand. Prior probability is the initial probability value without any additional information. Posterior probability is the updated probability of an event given some new information. And likelihood is the chance of observing a certain event, assuming another event is true. For classification problems, the Bayes theorem is used to calculate the probability that a data point belongs to a certain class, given its features. However, there can be cases where the probability of evidence is zero, causing division problems. To solve this, we add a small value to the variables, preventing the probability from turning zero. This adjustment is known as the Laplace correction. Despite its simplicity, Naïve Bayes classifier has its limitations, such as its poor performance with continuous features and its risky assumption of independent features. But don't worry, there's another algorithm that can handle these issues, the KN classifier. Moving on to our second star of the day, the K Nearest Neighbors, or KNN classifier. This algorithm is a versatile player in the field of machine learning, capable of tackling both classification and regression problems. Its power lies in its simplicity and its principle of operation, feature similarity. Imagine you're at a party and you don't know anyone. How do you find people with similar interests? You would probably scan the room, looking for people who are discussing topics you are interested in or behaving in a way that resonates with you. The KNN classifier does something similar. It classifies an object based on the majority class of its nearest neighbors. In other words, it predicts the class of a given data point by looking at the classes of its closest neighbors. This approach allows the KNN classifier to overcome some of the limitations of the Naïve Bayes classifier. For instance, the Naïve Bayes classifier assumes that the features are independent, which might not always be the case. The KNN classifier, on the other hand, doesn't make this assumption. It simply looks at the features of the nearest neighbors and makes a prediction based on their classes. This makes the KNN classifier a great tool to have in your machine learning arsenal. It's versatile, intuitive, and easy to implement. With these two algorithms, you now have a solid foundation in understanding machine learning. But remember, this is just the tip of the iceberg, and there's a world of algorithms waiting to be explored.